Homework 1.4 is on continuity. First, it asks you to sketch this piecewise function. Let's make sure our piecewise functions are good. It says the function will be x squared minus 1 when x is between negative 1 and 0. That is a parabola with a vertex at negative 1, and it goes up like this. Looks something like this. It is equal to it at negative 1. There's a point there. There is no point here, so we're going to put a blank circle for now. That's what our parabola, part of a parabola, looks like. It's y equals 2x between 0 and 1. Y equals 2x looks like this. And there are blanks on both ends. So I'm going to put a blank circle here and here. At x equals 1, the y value is 1. Between x is 1 and x is 2, the function is negative 2x plus 4. So that would start up at 4 and go down by 2, down by 2. It's going to look like this. And at 2, there is no value there. And the last thing is the function is 0 between 2 and 3. So it looks like this. So there's our piecewise function. There's a point at the end. We're asked to answer these questions about the graph. The first says, what is f of 0? F of 0 means what is the function value at 0, and we can do it two ways. We can use the equation, or we can use the graph. F of 0 means at x equals 0, what's the value? Well, this is when x is less than 0. This is when x is more than 0. There is no value at x equals 0. That's undefined. On the graph, we can see that there's no value at x equals 0 because when we look at x equals 0, there's not a point on either side. The limit as x approaches 0 from the right means when x is coming in just a little bit higher than 0, like right here, the y value is getting very close to 0. So that's the limit. The limit from the left is when x is just a little bit smaller than 0, the y value is getting closer and closer to negative 1. So even though the limits exist from the left and the right, there is no value at 0. Is f continuous at 0? We need to practice our limit definition. The three things we need is the limit as x approaches 0 from the left of f of x is 1. The limit as x approaches 0 from the right of f of x is 0. And f of 0 is undefined. All of these three things need to be equal to each other for the limit to exist, and none of them are equal. So it is definitely not continuous, and it's not even close to continuous. None of these things were true. We're not close to being continuous at f equals 0. On the back, we're going to work on two of these. This is a very common problem. You'll see it on your tests, your quizzes. We want to know, is g of x continuous at x equals 1? Well, you have to use your limit definition to be able to do it. Just making a claim without doing this won't get you any points. So we need to check three things. The limit as x approaches 1 from the left, g of x. The limit as x approaches 1 from the right of g of x. And what is g of 1? So these are the three things that all need to be equal. To do the limit as x approaches 1 from the left, when x is just a little bit smaller than 1, x will not equal 1, so we'll be on this section right here. So we just need to evaluate the limit as x approaches 1. The first thing we should do is direct substitution, and we get 0 over 0. So I'm going to use factor and cancel here. So what we're doing is we're going to do x plus 1 times x minus 1. I'm factoring the numerator, divided by x minus 1. And this factor cancels out. So we get x plus 1. And we're going to do the limit as x approaches 1 from the left. When we approach 1, this limit is 2. The limit as x approaches 1 from the right means x is just a little bigger than 1. And again, that'll be when x isn't equal to 1. When x is a little bigger than 1, x is not equal to 1. So we'll be on this section. And the limit will be the same because it'll still cancel out the same way. And so that limit is also 2. G of 1, now we're not on this section. When g of 1 means when x is 1, what is the y value? Well, when x is 1, the y value is 2, we're on this section now, this bottom section. And so this is 2. So limit as x approaches 1 from the left is equal to the limit as x approaches 1 from the right is equal to g of 1. They're all equal to 2. And so we want to say something like this. Limit as x approaches 1 from the left of g of x is equal to limit as x approaches 1 from the right of g of x is equal to g of 1. All of those are equal to 2. So g of x is continuous at x equals 1. Let's look at the last problem. The very last problem says what value should be assigned to a to make the following continuous. The first thing you should think is like, well, what does it need to be continuous? The limit as x approaches a from the left has to equal the limit as x approaches a from the right has to equal f of a. So let's see, what is the limit as x approaches a from the left, g of x? We just plug in, we need to see if we're approaching from the left, then x will not be equal to a, so we'll be on this section. And so we need to do this limit. We should try direct substitution. It's 0 over 0. That's the indeterminate form. So we're going to use factor and cancel here. This is x plus a times x minus a over x minus a. And that factor will cancel out. So all that's left over is x plus a. So the limit as x approaches a is going to be a plus a, which is 2a. So that's the limit as x approaches a from the left. The limit as x approaches a from the right will also be on this section. It'll be the exact same thing. So both the limits, the limit is 2a. When x is a, g of a is equal to 8. And we need these two things to be equal to each other. We need 2a to be equal to 8. And so we just set up an equation that says that. 2a needs to equal 8, so a is 4. That's the value of a that makes this function continuous everywhere. I hope that helps.